Very good morning, students. We have completed the chapter force and pressure, and tomorrow you are going to write the science examination. So, today we are having a quick revision on force and pressure. So, what is force? A push or pull. Push or pull acts on a body is called force. Push or pull acts on a body is called force, and the unit of force is Newton. In capital letter N, the symbol is capital letter N, or you can also write Newton with all letters should be in small letters. Now, then in the exploring force, we have to consider the directional property of force, because force is a vector quantity, then effects of force and the types of force. So in exploring force, we are having directional property, effects of force, and types of force. So what is a directional property? If forces are acted on a body in the same direction, for example, if two forces are acted on a body in the same direction, then in order to get the total force, or in order to get the net force, or in order to get the resultant force, we have to add the magnitude of the individual forces, or we have to add the individual forces. So in order to get the total force, when the forces are acted in the same direction, we have to add it up. And if the forces are in the opposite direction, then we have to take the difference of the two forces. So if 2 Newton force and 3 Newton forces are acted in the same direction, the net force is 5 Newton force. And if 3 Newton and 2 Newton forces are acted in the opposite direction, for example 3 Newton is acted in the east direction and 2 Newton is acted in the west direction. So one is acting east, another is acting west. So in this time the forces are in opposite direction. Here we have to take the difference of the two forces, difference of the magnitude of the forces. So it become 3 minus 2 is equal to 1 Newton. So if forces are in opposite direction, we have to take the difference. If forces are in the same direction, we have to add up. Now we have to go for the effects of force. In effects of force, the force can cause the change of state of motion of the body, meaning speed can be increased or speed can be decreased or direction can be changed. So these are the effects of force in its motion. And the force can also change the shape, size or volume of an object as well. For example, if I am squeezing lemon, the shape of the lemon get changed. So here what is happening due to force, the shape is get changed. If I am kicking a ball which is at rest, the ball will be moved from rest to motion. So here the speed is increased. Similarly, I can change the direction of motion of the ball also. So force can cause change of state of motion. When we say change of state of motion, if speed changes or direction changes or both changes, that is one of the causes of force. And the other one is shape or size or volume of an object also can be changed by applying force. For example, if we are hammering a piece of plastic, then shape of the plastic get be changed. So that is here the shape is getting changed. And if you are kicking a ball, the ball moves faster, so that speed is getting changed and the direction also we can change similarly. So in this situation, these are the causes, these are the effects of force. So effects of force either can be related with the motion or it can be related with its dimension, meaning the size or shape or volume. Similarly, now we have to discuss the types of force. Before discussing the types of force, we have to classify the force. The force can be classified mainly into two: contact force and non-contact force. If the force is applied because of the actual contact between the bodies, for example, in order to lift the duster, I have to touch it and I have to lift it up. So here actual contact is needed in order to move the duster from its initial position to here. So this one, the force exerted by my hand is nothing but a muscular force. So muscular force is an example for contact force. So an actual contact is needed. Whereas the apple falls or the object falls towards earth because of the gravitational force. Because of the gravitational force, in order to apply the force on an object by earth, the earth does not need to touch the object, so actual contact is not needed. If actual contact is not needed to apply the force, then such forces are called non-contact force. So gravitational force is an example for a non-contact force. So force is broadly classified into two: contact force and non-contact force. Muscular force is an example for contact force, whereas gravitational force is an example for non-contact force. Similarly, frictional force. When an object moves or tends to move over another object, here considering the duster is moving over my palm. So the duster, that is one of the object, and my palm is the other object. So when an object moves or tends to move, meaning tries to move on another object, a force is experienced between the surfaces in contact which opposes the motion. So friction is opposing the motion, or friction, and exactly we have to say friction opposes the relative motion. This gesture is relative motion with the hand. So this relative motion is preventing by the friction. So friction prevents the relative motion, or friction is always opposite to the relative motion. So friction is also an example for contact force. Friction is also an example for contact force. Now we have to discuss the magnetic force. A magnet can exert force on magnetic substance. Such force is called magnetic force. So in order to attract a magnet to an iron piece is attracted by magnet without the actual contact. So even the iron piece is a little away from magnet, the magnet attracts the iron piece. So here this is also an example for non-contact force. So magnetic force is magnetic force is also non-contact force. Now the other one is electrostatic force, the force due to charges. For example, if you are taking a scale and if you are rubbing our hair, and if you are bringing the rubbed scale to the small pieces of paper, the small pieces of paper get attracted by the scale, because while rubbing the charge transfer is taking place. So while rubbing, the scale get charged. So here the scale is get charged, whereas the paper piece is uncharged. So the charged body can exert force on uncharged body. So if there is a force or force due to charge, is can be called as electrostatic force, and this charge is actually at rest also. So the charge developed in the scale is charge at rest. That's why it is called electrostatic. Electrons, not just electron, the charge is at rest. So if the body exerts force due to charge, such force is called electrostatic force. Similarly, if you are now we are considering two balloons rubbed against silk. Now first one, let balloon 1, balloon 1 and balloon 2 are rubbed with the silk, so that the both balloon are get charged. Now if you are bringing the balloon together, then the balloon will be repelled, the balloon will be pushed apart or repelled. That is because of the electrostatic force. Here both bodies are charged, so a charged body can exert force on another charged body. Balloon 1 is exerting force on balloon 2. here balloon 2 is also charged, so charged body is exerting force on charged body. In the first case, the scale attracts the pieces of paper. The scale is charged body, whereas pieces of paper is uncharged body. So in first cases, charged body attracts or charged body exert force on uncharged body. In second case, the charged body exert force on another charged body. So that is here in second case we have taken balloon. So in a nutshell we can say a charged body can exert force on uncharged body as well as a charged body. A charged body can exert force on a uncharged body as well as a charged body. Now that is types of force is now finished. Now we have to move towards the pressure. What is pressure? Before discussing pressure, we have to discuss thrust. Thrust is THRUST. What is thrust? So thrust is nothing but if force is exerted perpendicular to the surface. We are considering this is our surface and force is exerting perpendicular to the surface. For example, here this is our surface and I am exerting force like this. So this is the thrust. Then here the angle between the surface and the force, the direction of force is perpendicular. So if the force is exerted perpendicular to the surface, such a force is called thrust. So thrust is nothing but a force which is normal to the surface, perpendicular to the surface. So other word of thrust is nothing but a normal force. Normal force. So force can be also, the thrust can also be called as normal force. So now we are imagining a boy sitting over the bench. So the contact surface we are taking as the force exerted by the boy on the bench we are taking as 300 Newton, and the contact surface we are taking as 0.25 meter square. So that is the contact area. This is the force applied. Now pressure is equal to thrust by area of contact. Thrust by area of contact or normal force by area of contact. What is the normal force? What is the thrust? Thrust is 300. What is the area of contact? 0.25 meter square. So 300 Newton divided by 0.25 meter square, which is equal to we can write it as 300 into 300 divided by 1 by 4. This 1 by 4 will come upside because it is in the order of A by B whole divided by C by D. So we can just write it as 4. So 300 into 4 is nothing but 1200 Newton per meter square. 1200 Newton per meter square. Also we can write pressure is equal to 1200. This Newton meter square is nothing but Pascal. P should be in capital letter, A should be in small letter. Pascal was also one of the scientists. So here the pressure is 1200 or 1200 Pascal. Now if the contact surface was 0.5 meter square, then what would be the answer? Here it become 2 because 0.5 is nothing but 1 by 2, so it becomes 2. So 2 into 300 it will become 600. It would have been 600 Pascal. It would have been 600 Pascal if the area of contact is 0.5 meter square. 5 meter square. Now imagine 0.5 meter square and here it is 0.25 5 meter square. So which one, where the area is small, here the area is small, so the pressure is less. Here the area is less, pressure is more. So if the area of contact is increasing, pressure will decrease, and if the area of contact is decreasing, pressure will increase. So in certain situation we will decrease the pressure by increasing the area of contact, and in certain other situations we will increase the pressure by decreasing the area of contact. We have already discussed some of the examples, so I am not going to go in the same examples. So let me move towards the other parts. Now here we have discussed the pressure due to two solids. Okay, so when a solid is placed over another solid, in the bottom surface there will be a pressure. Now what about the liquid? If we are taking a liquid into a container, the liquid will also exert force on the container. So the normal force exerted in unit area. What is normal force exerted in unit area? The normal force exerted per unit area is called pressure. So the liquid exerts pressure. Liquid exerts pressure. Not only liquid, the fluid, the gases also exerts pressure. So liquid plus gas we call as fluid. So fluid exert pressure on the container. So for example, if you are taking a imagine this is a water bottle. So we have filled the water from bottom to top. So in order to save the water column, this is the water column of height h. We are imagining this height as h. So what is the height? H is the height of the water column. If you are considering the point here and point here, the pressure will be more here or here. The pressure will be more here than here, because from here to here the height is more. From here to here the height of the water column. Height of the water column, from where we have to measure? We have to measure from top. So height of the water column is more from here to here than to here. So the pressure increases with increasing the height of the water column or height of the liquid column, and same is applicable for gas also. The height of the column meaning from top we are measuring to till the point. From top to till the point if we are measuring, that is the height of the column. So as the height of the column increases, the pressure increases. The pressure will be more in down than in the middle or in the upper side of the bottle. Similarly, if you are considering a number of points in the same horizontal plane, in the same horizontal line, or in the same level, in all points the pressure will be same in all points. So in every direction the pressure will be same if the level is same. So liquid exerts equal pressure in the same level, and the pressure will be more when height of the column is increasing. And I told the height should be measured from the top. Now if you are considering the earth, the blanket of gas surrounding over the earth or on the surface of earth is called atmosphere. So due to the atmosphere, there will be a pressure, and the pressure due to the atmosphere is called atmospheric pressure. Pressure due to the atmosphere is called atmospheric pressure. If you are considering the atmospheric pressure, then we already told it as the height of the column increases, pressure will be more, and the height should be measured from the top. So just consider like this. This is our typical earth. Okay, now here we are having this is a blanket of air, and I told the height should be measured from the top. So this is from here to here. This is the total height of the air column. So if you are considering this point and this point, where will be the pressure will be more? In this point the pressure will be more because the height of the air column is great or more than here. Here the height of the air column is less. So if a person is going higher over the surface of earth, then atmospheric pressure will be less. So atmospheric pressure in this point and atmospheric pressure in this point are different. Here the atmospheric pressure is higher, then here the atmospheric pressure is lower. So if a person is going to mountain, the atmospheric pressure will be less than the sea level. Here we are taking this as sea level. Here let it be in mountain. So if you are considering the atmospheric pressure in sea level and atmospheric pressure in mountain, the atmospheric pressure in sea level will be more than atmospheric pressure in mountain because of the difference in the air column. Because of the difference in the air column, there are some other points also. Now, now you imagine if the air is exerting pressure on us, why we are not crumbled or why we are not crushed due to the atmospheric pressure? It is because inside our body there is blood. The blood also exerts pressure. So the blood pressure cancels the atmospheric pressure. That is why we are not crushed under the huge atmospheric pressure. So there is a good chance of asking a question from this point. And the other one is in the pressure. There are certain situation we did not discuss. For example, a camel can walk easily over the sand than a man because camel's feet or the feet will be broadened than the feet of a person. So if feet is broadened, meaning area of contact is more. If area of contact is more, pressure will be less. So the pressure will be less because of the broadened feet of camel. So the camel can walk easily than a man because the pressure over the sand due to the weight of the person will be more than the pressure created by an animal because the difference is area of contact of the feet. Now if you are using the heels and the flat soles of chappals, the shoe having heel will be having more pressure, okay, because of the less area. Anyway, now I hope you understood. When while we are moving up, the height of the air column decreases. Because of that, the pressure will be less. And there is the blood pressure, we have to concern about it. Then what else is there? Okay, that's enough for you, to as a revision. That is enough. So you will be having question in an application level. You will not be asked maybe what is a unit of force, or you may not be asked what is a unit of unit of pressure. There is a chance of asking the unit, but some of the question will be in application level where you have to understand the concept, and this concept should be applied into that particular situation, and you have to get the answer. So some process should be done in your mind, so only you will be getting the answer. But whatever process has to be done, it should be gained from our concept. So I hope you enjoy the video. Now I am winding up it because you are already in a mode of examination, so I don't want to elaborate the things. I had the quick revision over the concept, that's all. And I have already forwarded the materials, and I will forward some more materials, okay? So prepare well. This is the first examination that you are going to write in the academic year 20 to 21. So 2020 to 2021, this is the first examination that you are going to write in your CBSE as a unit test, okay? So prepare well and write the examination well, and very best wishes to you all. Good. Okay, thank you.